All right, everyone. So we're looking at the triple doses today. How can I find the length? Here we're adding integers and rational numbers. If you're not sure what an integer is, well, it says integers are positive and negative whole numbers, which would mean 1, 2, 3, and so on, but also -1, -2, -3, -4, and so on. And then we also have rational numbers, which would be fractions and decimals. And so we're going to add these lengths or combine these lengths in multiple ways to find a new length. And so, for example, if we look at 3 plus 3 plus -2 plus 11, it's saying we would move forward 3, move forward 3, and then we're going to move backwards 2, and then move forward 11. And that would put us at, let's see, 3, 6, 4, 15. So if we look at this first problem here, it says find the lengths of the tightrope if each expression for ropes started Cecil at point A and had him end at point B. Assume the numbers represent lengths in feet. And so here we're saying if Cecil moves forward 8 feet, and then he moves back 3 feet, and then he moves forward 2 feet, what would the total length of the rope need to be? All right, so 8, and then we're at 5, and then we're at 7. So I'd say 7. All right. And then we're going to do the same thing, but here we have some tougher problems with fractions. Remember, with these denominators here, we have 3, 2, and 6. Could we find a common denominator to make adding these fractions together a little bit easier? Think about that. And then it says for 243, for Cecil's new act, his tightrope is 5 feet long. And here we see a picture, A to B, that's 5 feet. There's Cecil waving to us. Hi, Cecil. And it says if he begins at point A, write 2 expressions that will make him end at point B. What do these expressions have in common? All right, so you're just going to write 2 expressions that will get him from point A to point B. Remember, that's 5 feet. And then here, part B, you're going to explain why this equation here is equivalent to just simply saying, Cecil, move 5 feet to the right. Okay? And then we have part C, and it's asking if this equation here will get Cecil to point B. We'll get him to move 5 feet to the right. And then how about this equation? Will this get him to move 5 feet forward? And then how would you describe his movements in these cases? I would simply draw a number line and explain it that way. And then 244 says, what if Cecil's tightrope was a number line, like the one shown below? So here's our number line, and you're going to sketch this down on your paper. And it says, how can you represent -2 plus 3 using a number line? Okay, so here I have my number line. How could I represent -3? Is that what it's saying? Nope, -2 plus 3. All right, how could I show that? And then where would I end up? So you're going to explain with your group members what you did and why you did what you did. And then we're moving down to 245. And here it's talking about absolute value, okay? And so it says, in part C and D of problem 244, you may have discovered that for each of the pairs of computations, the distance that you moved on the number line from each starting value was the same. This was true even though in one case the number added was positive, and in the other case it was negative. The sign of the number added told you in which direction to move, while the size of the number told you how far to move. And so the amount that you move in one way to describe the absolute value, the amount that you moved in one way to describe the absolute value of the number. All right. It's basically just saying like, how far did you move in total? Okay. So for example, if I look down here and I moved 20 in the negative direction or 20 backwards, and then I moved 5.3 in the negative direction or 5.3 backwards, how many total feet did I move? All right. That's what it's asking. In here, part B, if I move 45 in the positive direction and then another 7.7, how many total feet did I move? All right. And here it explains that absolute value is shown here in these little brackets. All right. And you're going to always have a positive number because think about it. Can you move negative feet? No, you can't, right? You can only move a positive length of feet, but you can move in the negative direction, and that's why we have negative numbers here. But if I move -20 in the negative direction, I moved 20 feet in total. So here at 246, it says making zeros. And it says for Cecil's newest act, he starts at point A on the left end of the tightrope and walks on the tightrope, turns around, sometimes many times, and then ends up back at point A on the left end of his tightrope. Okay, so now here you're going to work with your team and write at least 3 expressions that show Cecil could move and still start and end at point B. So in other words, let's say I move 5 feet forward. Well, how would I get back to point A? Well, I have to move 5 feet backwards, right? Move 7 feet forward, I have to move 7 feet backwards. And you can be creative with your expressions. And then here it has a question about the temperature rising. Okay, so you go in the positive direction and then the temperature drops. So you'd bring it back in the negative direction. And so I would again draw a diagram just like it says here, but I have bigger numbers than this. And then I move in the positive and negative direction to see where I end up. And then it says for 248, Gina was working on the previous problems when she had a new idea. She says, look, I can use these ideas to add large integers quickly without even picking up a pencil. Boy, aren't you smart, Gina. And so what we're going to do here is try to figure out how Gina solved these so quickly. And if I'm looking at this problem, for example, I might think of a strategy like, okay, I see 300 in both numbers. And so if I take my 313 and I add my negative 300 to it, they would cancel out, right? Just if you had 1 and you added a negative 1, they would cancel out. And so if I were to cancel out my 300, I'd have 13 and 6/11ths left over. So that'd be my strategy of solving that one really quickly. And then it says for 249, consider Cecil's movements on a tightrope as you answer the questions below. And so it asks what happens if she goes forward 5 feet and then goes back 5 feet. And then here they show with these little positive marks and these negative marks how to cancel out numbers like we just talked about. All right. And then for this learning log, you don't need to fill out a learning log. Simply write the response down on your paper and then submit it with the rest of your work. Here it goes over what integers are. And here's the homework. A lot of this is basically what we had just gone through. This here might seem a little confusing at first, A and C, but if you go to the homework help, this is always super helpful. It says we're going to line up these positives with our negatives to see which ones cancel out. And then once we do that, we, for example, have 2 left over here, which is shown in this equation, right? The 3 zeros, the numbers that cancel out. And then we have the 2 left over, and so our answer would be 2. So remember, use that homework help. It's very helpful. And then here we're talking about terminating and repeating decimals. So think about terminating, right? I am the terminator. I will end you. So terminate means end, repeat. Well, that means you'll repeat and continue to go on forever, basically. And then this one here, 255, you're going to have to look at finding common denominators because it asks about putting half of the money in a savings account and then spending a fifth. And so how could we write 1/2 or 1/2 and work with it in relation to our 1/5? Like, what is our common denominator between those two fractions? And that'll help you figure out the problem there. So yeah, please submit all of this work, both the core problems and the review and preview problems. Let me know if you have any questions. But that is basically the overview of what this lesson is all about. Thank you very much.